Yeah, so welcome everyone. My name is Tamban Devi, aka the scientific engineer. Yeah, so today we are going to talk about binary operations, putting it in a way whereby it's easy to understand so that even when you are tackling questions, it may be easy for you. So today we'll go through the basics and also the laws of binary operations, because in binary operations there are laws to follow and examples also. So let's not waste time and start. So a binary operation. A binary operation is simply a rule that takes two numbers and combines them to give one result. So what do we mean? So the first thing which you should understand is that we are saying a binary operation is simply a rule that takes two numbers and combine them together to give one result. So you should understand these two words. There is binary and operation. When you say binary, binary means two. That's what binary means because of this word bi. When you go to operating means connection, which means you are connecting two things to give what? A result. So we're going to say A operation, B, which means A connecting A and B, it's going to give you a what? A result. Yeah. So for example, e.g., we are going to say 2 plus 3 is equal to what? 5. So we are connecting these two things, what? 2 and 3, which means to give us a what? A result. So as we said earlier, a binary operation is simply a rule that takes two numbers or objects and combines them to give a result. Now after being done with that, let's go to the important properties of binary operations. So we are saying like the important properties of binary operations. So to understand binary operations better, we look at some properties, and these properties are the first one. The first one is closure. What do we mean closure? Closure means the result must stay in the same set. What we mean here is, for example, if we say 2 plus 3 is equal to 5, the closure property holds here. Why? Because 2 plus 3, this 2 plus 3 is, we can say they are natural numbers. Even the result is what? Is a natural number. So for example, if we take for instance, if the set was saying like it's a set of natural numbers, like you add 2 plus 3, for example, you get -5. This is just an example. It's even wrong. Closure property doesn't hold here because like the answer, these are natural numbers, but that one, it's not a natural number. It can be an integer. Yeah, so that's just what we mean when we say closure property. Yeah. We go to the second important rule, which is commutative rule. So when we are talking about commutative rule, we are saying order doesn't matter. So in commutative, order doesn't matter. For example, when you say A star B is equal to B star A, here even if you start with A or you start with B, the answer is still the same. Let me write it properly here. A star B is equal to B star A. So the order doesn't matter. You can start with anything. Again, we can use the same example. I don't want to be using difficult examples. My goal it's for you guys to understand in simple ways. Even when you tackle difficult things, you understand like where it's coming from. So for example, the same example, 2 plus 3, this can be equal to 3 plus what? Plus 2. This is commutative. This is commutative because even if you start with 3 or you start with 2, the answer is still the same, the result. But 2 minus 3 cannot be equal to 2, or let me say 3 minus 2. So here commutative doesn't hold. So commutative it holds, it agrees on addition and subtraction, not addition and multiplication, but not subtraction and division. So that's one thing you should know. It holds when we are talking about multiplication and addition, but not subtraction and what? And division. Yeah. So we go to the third one, which is associative. When we are talking about associative grouping doesn't matter. So in commutative we said order doesn't matter, but for here grouping doesn't matter. Let me write it here. So in associative, grouping doesn't matter. So what do we mean say when we say grouping doesn't matter? I'm going to give like the example. You have A star B. This is grouping. That's what we say grouping. Like you are putting things together. Star C is equal to A star B star C. So if you see here, we started with A star B, but here the one we grouped what? B and C. So it doesn't matter, the answer is still going to be the same. So that's what we mean when we say associative. So it's very important for you guys to know these laws. They may give you questions like they will ask you, is this associative, is this commutative? Or sometimes they may tell you, they will give you a question and they will say you test all the laws. So you say closure law, commutative and associative, and the others you test if. So you just need to know this definition, then it's going to be easy. So the fourth one is nothing else but identity element. So identity element, it means there exists an element E such that, so there exists an element such that A times E is equal to E times A, which is equal to A. So when we are talking about identity element, we mean like a number whereby if you multiply with that number, the answer which you are going to get is the same number, but not the one. It just helps you to return the original object you have multiplied with. For example, I say A times E. This is equal to E times A. It just means commutative. You can start with A or E. The answer is what? A, which means this is an identity element. So, example, when you say 1 times 6 or 6 times 1, the answer which you are going to get is 6. So 1 is an identity element. As easy as that, guys. So let's go to the fifth one. So for inverse element, I think we have read this a lot. So for inverse element, we say there exists an element. For each element, there exists another that undoes it. So it's like the opposite of that number. It undoes it. For example, we may say the inverse of 5 is what? Is negative 5. So that's just what we mean when we say inverse element. It undoes it. The inverse of negative 5, again, it goes back to 5. The inverse of 5 again is what? Negative 5. Yeah. So these are the laws that we have on binary operations. So I think we are almost done with the topic. But the only thing which is remaining is which I'm going to cover in the next example. We will do almost even 5 questions. Some will be from exam papers, some will be from examples like from lectures, like, and all that, so that you test yourself. But then if you can understand this, I'm telling you, things are going to be easy. I've already said it, that for me, I believe that when you understand the basics, then everything can go well. But people usually think that when I say basics, it doesn't mean that the basics are the ones which are coming in the exam. No, the basics help you to, even if you haven't solved that example before, or you haven't solved that exam question, you may try, and you might be able to to come up with the answer. So let's not waste time. Bye guys. See you in the next video.